Today we're going to take another look at simplifying expressions, including a few definitions, some tips and hints for simplifying, and then some examples. Okay, so when we're talking about a term, what we're talking about is a number, a variable, or the product of numbers and variables. So for some examples here, a term could be just 3, term could be 5x, it could be 3xy, it could just be 10. It can be any of these where there's no addition, there's no subtraction. We're just multiplying, or we just have a number or a letter. Okay, and then the second word you're going to need to be familiar with is coefficient. So a coefficient is the number that comes in front of the variable. So in the examples up above here, the coefficient in this term is the 5. The coefficient in this term is the 3. And so we could have a couple more examples here. We could have 3m or 10xy, and in each of these the coefficient is just this number that's in front of the variable. Okay? And then one final thing I want to note before moving on is just a reminder that when you see x, that's the same thing as 1x, and if it helps you to put the 1 in front, you can. On the same hand, if you ever see a negative x, that's the same thing as a negative 1x. And again, this page just has some reminders. Remember, like terms are terms that have the same variable, and they also have to be raised to the same power. So x and x squared are not like terms because they have different variables. The coefficients do not have to be the same. And then also remember that the constants, or just those regular numbers that are being added or subtracted, are also considered like terms. Okay, and then you'll see in the example here, this green box has a lot of examples of like terms, and the red one has examples of terms that are not like, or they're unlike terms, and then there's an explanation for each. So you can pause and read this over on your own, and then move on when you're ready. Okay, and here's kind of a visual just to remind you. When you're talking about exponents with different powers, we cannot combine them. We can't add them together. So the example here is a p cubed and a p squared. And so they have you visualize like PlayStation, right? PlayStation 3, PlayStation 2 are not the same thing. They're different systems. They're not identical. You can't just combine them and say you have two. Okay, it works the same way with variables. Okay, p to the third and p squared are not like terms. Okay, same with if you have x to the fourth and x to the seventh, those are not like terms. Okay? Okay, and then some reminders as you're simplifying. My tip that I always tell you guys is to highlight or to circle or box up the terms that are the same as you're simplifying them. Make sure you include the sign in front. That's super important. And then sometimes you find it's helpful to add the opposite before you go through and simplify. So let's look at this example and kind of apply those reminders. Okay, so I'm going to go through first and kind of box up all my x's, and I'm going to make sure to include the sign that's in front of them. So I have 3x, and I have a positive 2x, and I have a negative 5x. And so if I combine those three terms, I have a 3 plus 2, so that's 5, and then minus 5, that leaves me with 0x. Okay, and then we'll simplify that in a second, but right now we'll just leave it as is. And now let's combine our constants. So I've got a negative 6, and then a negative 3, or taking away negative 3. I'm going to make that easier by just doing that as adding the opposite. So this is just a 3. And then I also have a positive 7. So I'm going to add my positives first. 3 plus 7 is 10. And then I have 10 minus 6, which is 4. So since it's a positive 4, I'm going to do plus 4 here. Okay, now at the bottom you can see I have 0x plus 4. Well, I don't want to end with 0x. That's not simplified. So this really just simplifies to 4, because if there's 0 x's, we don't need to write that at all. All right, let's look at another example here. On this one, I'm going to go through, and I can see I have m squareds and I have m's. So let's go through and box those up as we simplify. I'm going to start with my m squareds. So I have negative 3m squared, and then I have a negative negative, or subtracting a negative, 8m squared, and that's it there. So I'm going to turn my subtracting a negative into adding the opposite, and so that leaves me with a negative 3 plus 8. Well, negative 3 plus 8 is 5, and so that means I have 5m squareds. And then let's look at our m's. I have a positive 4m, and then I've got adding a negative 2m. Now, some people would just circle the negative 2m. That's fine also, since we're adding. I just always like to include everything in front. And then I have a minus m, and I'm going to throw a 1 in front of that as a reminder to myself that that's like a negative 1. Okay, so then I've got, if I'm combining these, I've got a 4 plus a negative 2, so that makes 2. And then 2 minus 1 is 1. So I have 5m squared plus, instead of writing 1m, I'm just going to put m, because we typically leave the 1 off, although it's not wrong if you put it on there. Okay, so 5m squared plus m is my simplified expression. And for our final one, we now have one with xy's, m's, and also constants. So I'll go through and box up my xy's first. I have a negative 3xy plus 4xy. So negative 3 plus 4 is 1. So that's 1xy. Next, I will go in and grab my m's. I have negative 2m minus negative 6m. Again, subtracting a negative we know is adding a positive. So this is negative 2 plus 6, that's 4. Since it's positive 4, you can just write plus 4, and those were m's. And then finally, I've got some constants here. Don't forget, way over here, this guy's almost got overlooked. I've got a 1 and a positive 2. Well, 1 plus 2 is 3. Again, it's positive, so I just do plus 3. Okay, now again, I don't have to write the 1 in front of my xy, so when I go to write my final simplified expression, I'll just put xy plus 4m plus 3.